Hello and welcome to Unit 11, Lesson 1, Angles and Angle Measures. This is our first lesson in more of our trig part of our class. And so we're going to kind of be taking ideas that you saw in geometry and expanding on them. And so that's the reason for your warm-up. So given the triangle, find the 6 trig values for the theta. We're going to go over this in class, so please come with this completed in class. What we're going to do now is we're going to go over some definitions. I want to start by just looking at the first 3. Standard position, it is an angle position so that the vertex is at the origin and the initial side is on the positive x-axis. Initial side, the part of an angle that is fixed on the x-axis, and your terminal side is the part of an angle that rotates about the center. So with a highlighter, standard position, these 3 things start with what's on our first page. So when graphing angles, theta, we will graph on the coordinate plane x and y axis starting in quadrant 1. This is called an angle in standard position. Okay, you're just basically graphing an angle. Then we have our initial side. So this is a fixed starting point on the x-axis. And then we have our terminal side. This is the part of an angle that rotates about the center. This is can move, and it depends on the angle you're given. And so what this creates is your angle of rotation. Our other 2 words we're going to learn about later in our lesson are coterminal angles, which are angles in standard position that have the same terminal side. And a radian is a unit of angular measure equal to 180 degrees over pi, or about 57.296. So we have our angle of rotation in standard position. Now we can have positive and negative angles. We still will have, they both have their initial side in the same spot. Now, depending on if it's a positive, we rotate counterclockwise, again, ending in that terminal side. And if it's a negative angle, we are going to go clockwise, still ending with our terminal side. Okay, so what we're going to do on the next page is we are going to graph in standard position. Now, you saw it on the other page, but I'm bringing it over here. It's just splitting your quadrant into your angles to kind of help. So we get a perfect right angle, which is 90 degrees, a perfectly straight line, which is 180, 270 degrees, and then a full rotation is 360 degrees. The reason knowing this is helpful is it will tell us, okay, 60 degrees, that's between 0 and 90, and so it's closer to 60 than it is to 90. So we're going to start with our initial side. We're going to go counterclockwise because it's positive, and that's our angle. Okay, so now we have negative 45 degrees. So we're going to start with our initial side. Negative 45 is going to go clockwise. Well, that's halfway between 0 and 90, and so that creates our negative 45 degree angle. Okay, so we have 140, it's positive, so again, initial side. Well, it's greater than 90, but less than 180, and it's about halfway between. And so there is our angle, and we're going to graph this to represent where our angle is. It tells us if it's positive or negative. Okay, let's keep going. So again, starting with our initial side, negative 120, it's greater than 90, which is going to be right here, but it's less than negative 180. And so it's closer to 90 than 180, and so we're going to have that negative angle. That's why this piece right here is so important. Okay. Now the problem with 400 degrees is that it's greater than a full rotation. So what we're going to do is we're going to take our angle and subtract 360. That is one full rotation. And so what we get is 40 degrees, positive 40 degrees. And so what that's going to look like, starting with our initial side, going counterclockwise because it's positive, we go all the way around. That's one full rotation because we've done 360 and a little bit more for that 40 degrees that we have extra. Okay, our next one we have negative 600 degrees. So I'm going to take my degree and I'm going to add 360. That is one full rotation, which will give me negative 240 degrees. Well, that's between 0 and 360. So again, we're going to start with our initial side. We're going to go clockwise because of the negative angle. So there's 360, and then I have negative 240, and that would create my angle in standard position. Okay, so we now have coterminal angles. I talked about this earlier in our definitions. These are angles that share a terminal or ending side. They start and end at the same place. Let's look at 30 degrees in standard position. So here is 30 degrees in standard position. Forgot this. Tells us if it's positive or negative. So how could you find a similar angle that ends here? Take a moment, think about this. Well, we can, because we can go all the way around both ways. So we could have a positive, or we could have a negative angle, like that. Oopsies, wrong way. We always start at our initial side. We could look like that. And so what we're doing is we are going to be adding, or I'll just do last, subtracting 360. It's kind of like just making a big circle, and you're going to end up at the same spot. So if we take 30 degrees, another possible angle is if we could add 360, we would get 390 degrees. So that is a positive coterminal angle. Now let's see what happens if when we subtract 360, we get negative 330. That's going to be our negative angle. And don't forget your degree symbols. Okay, so that's what we're going to do on the next page. To find coterminal angles, we can add and subtract 360 degrees. Sometimes to find a positive and negative coterminal angle, you might need to only add or subtract 360 degrees from the angle depending on the sign of the given angle. We'll see that more in E and or in C and F. So what we're going to do is we're going to find a positive and negative. So here's 60 degrees. I'm going to add 360 degrees, and we get 420 degrees. There is our coterminal. Now I'm going to take my angle and I'm going to subtract 360 degrees, which will give me negative 300 degrees. Okay, let's look at B. So we have 210 plus 360 degrees. This will give us 570 degrees. Again, don't forget your degree symbol. Now we're going to take that same angle and we're going to subtract 360 degrees to get negative 150 degrees. Now C, I talked about it earlier. 390 is greater than 360 degrees. So it's going to have one full rotation. So we can still take our angle and add 360, which will give us 750 degrees. So there's our one positive angle. Now, if we take our angle and we subtract 360, we get 30 degrees, which is still a positive angle. So what happens here is we now have to take 30 degrees and subtract 360 to get a negative angle, because we need one positive and one negative. So technically, you could have multiple answers for these types of problems. So let's keep going. So for negative 300, I'm going to take negative 300 and add 360, which will give me 60 degrees. Now I'm going to take that angle, and I'm now going to subtract 360, which will give us negative 660 degrees. E, we got negative 20 plus 360. Again, you should be able to do this in your calculator. We're just writing it for a note so we can see what happens. And then I'm going to subtract 360, which will give us negative, don't forget that, 380 degrees. Now F, again, it's greater than 360. So knowing that, what we can do instead of just always adding, we can take 730 and subtract 360 degrees, which will give us 370 degrees. So there's one. Now, if we take that angle and subtract 360, we actually still get a positive degree. So we have to now take that angle and subtract, my degree symbols are looking a little weird, 360, which will give us now a negative degree. And technically, you could have 370 degrees or 10 degrees and still get full credit because it's still a coterminal angle. Okay, so now what we're going to do here is we're going to find a coterminal angle that's between 0 and 360. So you just have to figure out what you're going to do. So this is less than 0, so we're going to add 360, which would give us 240 degrees. Now B, that's greater than 360, so we want to subtract it, which will give us 40 degrees. C, it's greater than 360, so we're going to subtract it, and what we get is 430 degrees. Well, that's still not between 0 and 360, so we have to do one more to get 70 degrees as our final coterminal angle between 0 and 360 degrees. So for example 4, I want you to do this on your own, and we will go over this one in class. So have number 4 done. What we're going to do now is we're going to go into angles in radians. So 1 radian, it's an angle that creates an arc length that is equal to the radius. So this radius is going to be the same as our arc length, which is technically the same as this radius. It creates this like pie slice. So let's kind of understand what 1 radian is equal to. These questions kind of help set it up. So what is 1 rotation equal to? 360 degrees. That's 1 full rotation from here all the way around is 360 degrees. Now our circumference formula is C equals 2 pi r. So with this in mind, what is 1 radian equivalent to? Well, if this is our circumference, we're going to take 360, set it equal to 2 pi r. Well, if we isolate r by both sides by 2 pi, we get 57.295, which we saw in our definitions, and so we get 57.3 degrees, which it kind of looks like that. If you think about it, here's a perfect right angle. It's about 60 degrees. Now, because the circumference of the formula is C equals 2 pi r, if we let our radius be 1, then the circumference of 1 complete rotation is 2 pi. So we're going to use this to find some angle measurements. The reason we're doing radians is that a lot of the times you'll use radian measurements in calculations. You won't always use degrees. So if we have 1 full rotation, we have 2 pi. So 1 full rotation would end up right here, and so that's going to be 2 pi. Now, 180 is half a rotation. So what's 1/2 times 2 pi, which gives us 2 pi over 2, which is pi. So what we've just found out is 180 is pi. Now 90 degrees is 1/4 of a rotation. So 1/4 of 2 pi, we would get 2 pi over 4 because when we multiply across, which simplifies to pi halves. Eventually you will start to remember these. So with this, we can actually turn degrees into radians and vice versa. So to convert, we are going to do pi radians over 180 or just pi over 180 degrees. And then if we want to turn radians to degrees, we do 180 degrees over pi. Now, what helps to figure out which fraction you're doing, think about what you want to cross out. We want to cross out that degree sign, and this kind of brings in chemistry. So if we want to cancel that out, we want 180 degrees on the bottom. So that's why pi goes on the top. So the degree symbols cancel out, so we get 270 pi over 180. Now we can't leave it like that. We need to simplify. Now you can do it a couple ways. You can do it by hand, so we get 27 pi over 18. Those both have 9 in common, which will give us 3 pi over 2. You can also, remember, do your calculator where you plug in 270 divided by 18 and press second PRB to convert it. And so we're going to do B, so converting 4 pi over 3 into degrees. So 4 pi over 3, again, we want to cancel out that pi, so that pi is going to go on the bottom. We have 180 degrees. So again, the pi's cancel, which is what we want. So we get 4 times 180 over 3, which is 240 degrees. So there's our answer. Okay, let's go on to the next page. So all we're going to do is convert the following into radians. So we have 40 degrees. Again, we want to cancel out that degree symbol. So the degrees cancel. You can also cancel if you want instead of using your calculator. They both have the 0 in common, so we get 4 and 18. Those both have 2 in common, so we get 2 and 9, giving us 2 pi over 9. Okay, let's look at 300. So we again want to cancel out that degree symbol. And so I'm going to write it as 300 pi over 18, oopsies, 180. I'm going to plug that into my calculator and press second PRB to get 5 pi over 3. And then C, we got to be aware that there is a negative symbol. So we have negative 30 degrees times 180 degrees on the bottom, and then pi on the top. The degrees cancel out, so we get negative 30 pi over 180 because we multiply across. And when we simplify, we get negative pi over 6. Okay, now we're going to convert the radians into degrees. So we have pi over 6, and we want to cancel out the pi, so the pi is going to go on the bottom. So pi's cancel. We get 180 degrees over 6, which will give us 30 degrees. B, again, be aware of the negative sign. So we have negative 4 pi over 3 times, again, the pi's need to cancel out, so I'm going to cross cancel. So what we're going to plug into our calculator is negative 4 times 180 over 3, which is negative 240 degrees. Again, don't forget that degree symbol. And C, our last one here, we have 3 pi over 4, pi on the bottom, 180 on the top. Canceling the pi's, 3 times 180 divided by 4 is 135 degrees. Eventually, these will become a lot faster because a lot of what we've seen so far is actually going to be on our unit circle that we're going to be talking about later in our unit. So we can also graph radian measures in standard position. So there's 2 ways that you can do this. First way is eventually you will know, okay, 0 pi halves, pi, 3 pi halves, and 2 pi. So just by knowing that, here's our initial side, go all the way around, ending here. And as you get to know your unit circle, it'll be a lot easier to graph these. But if you didn't know your unit circle, what you could do is you could convert these into degrees. And so again, the pi's cancel, and we would get negative 330 degrees. So again, initial side, it's greater than 270. It's pretty close to 360, and that creates our angle. And so again, for C, we're going to multiply. We want to cancel out that pi. So the pi's cancel, multiplying across, we get 120 degrees. And so initial side, it's greater than 90. but closer to 90 than 180, and there is our angle. We can also find coterminal angles if you haven't figured it out already. All the stuff we did with angle or with degree angles, we can do with radian angles. So if we think back, we added and subtracted 360 to find coterminal angles. What do you think we will add and subtract to find a coterminal angle? Well, if we're working with radians, 360 degrees is 2 pi, so we're going to add and subtract 2 pi. Well, we're dealing with fractions. So the problem with that is to add fractions, we have to have the same denominator. So we're going to multiply 2 pi by what ends up being just always your denominator. And so we get 2 pi over 3 plus 6 pi over 3 equals 8 pi over 3. It's that easy. Now what's nice is that to get our negative angle, we're going to bring everything down. The only difference is now we're going to subtract, and so 2 minus 6 is negative 4 pi over 3. And that's what we're doing. So the biggest problem people have here is turning 2 pi into a similar fraction. So again, all we're going to do is multiply by the top and bottom, second over 1, by our original denominator. So we get 7 pi over 6 plus 12 pi over 6. And if we multiply, oopsies, not multiply, add, we get 19 pi over 6. And then I'm going to do the same thing, but I'm going to subtract 2 pi, which is 12 pi over 6, to get negative 5 pi over 6. Okay, let's go to the next page. We're going to do some practice problems. Here we go. So I'm going to add 2 pi over 1, so that means I'm going to multiply by 8. So we get negative 9 pi over 8 plus 16 pi over 8, which is 7 pi over 8. And then I'm going to subtract, so 9 pi over 8 minus 16 pi over 8, forgot to circle it, is negative 25 pi over 8. Don't forget that negative sign. Okay, so for B, I'm going to add 2 pi, so I'm going to multiply that by 2. So we get 7 pi over 2 plus 4 pi over 2, which is 11 pi over 2. Now, you might start to see, oh, 7 minus 4 is 3 pi over 2. That's still positive. We're looking for a negative, so it's actually going up. So now what I'm going to do is 3 pi over 2 minus 4 pi over 2, which is our negative angle of negative pi over 2. Now, if you don't get that, that's okay. It's just a faster way to add and subtract radians or find a coterminal angle. So I'm going to add 2 pi. I'm going to multiply the top and bottom by 3. So we get pi over 3 plus 6 pi over 3, which is 7 pi over 3. And I'm now going to subtract that 2 pi, which again is equivalent to 360, to get negative 5 pi over 3. And there's our coterminal angles. Last example, because you're going to do example 12, and then we're going to go over it in class. We're going to find a coterminal angle that is between 0 and 2 pi. So this is greater than 2 pi, because I know it's greater than that, because 5 times 2 is 10. So that means I'm going to take 14 pi over 5, and I'm going to subtract 2 pi. The reason that this helps is figuring out if we need to add or subtract. So we get 14 pi over 5 minus 10 pi over 5, which is 4 pi over 5. This should always be less than 2 pi, which we already found. So we're good there. B, this is still greater than 2 pi because that would be equivalent to 6 pi over 3. And so what that means is we're going to take 8 pi over 3 and subtract 6 pi over 3, which will give us 2 pi over 3. And our last one, this one is actually less than 0, so that means we have to add negative pi over 4. We have to add 2 pi, so negative pi over 4 plus 8 pi over 4 is 7 pi over 4. Okay. Now I want you to try number 12 on your own. We will go over it in class together.